In this video, I'll be looking at applications of systems of equations. So it says here, write a system to model each problem. Use the system to solve the problem. So these are considered some of the basic types of problems you'll run into when you first start doing applications of systems. And it's certainly possible to solve these by other means. But the whole point here is, first of all, this is an algebra course, so we're learning how to use algebra to solve problems. And the other thing here is we're working with systems. And so in each case, you need to write a system of equations that represents the problem, and then use that system to solve the problem. All right, so let's go ahead and get started. On number 1, it says the perimeter of a soccer field is 360 yards. The length exceeds the width by 40 yards. Find the length and the width of the field. Well, first of all, I would draw a soccer field, and I'm going to call the shorter side the width and the longer side the length, which is pretty standard. And it does say the length exceeds the width by 40 yards, so the length is the bigger side. Excuse me. So it does say the perimeter of a soccer field is 360 yards. Now there is a formula for the perimeter of a rectangle. It's P is equal to 2 times the width plus 2 times the length, or 2W plus 2L. And so we can write 360 is equal to 2W plus 2L. So there's one of our equations in W and L. You'll notice I'm using W for width and L for length. We could have used X and Y. Now, the other statement we have here that's going to help us to write an equation is where it says the length exceeds the width by 40 yards. So the length is basically bigger by 40. And so I'm going to go ahead and write Y or L equals, L for length. So how do I say basically 40 more than the width? It exceeds the width by 40. So 40 more than the width, we would say W plus 40. And so now we have our system. Now I'm going to go ahead and rewrite this. Actually, let me go ahead and substitute first. I'm going to use the substitution method here since the second equation is solved for L. So let's do that first. And then I'm going to go ahead and switch sides. Put my variables on the left. So let's go ahead and simplify the left side. We have 2W plus, and then we'll distribute 2 times the W plus 40. We get 2W plus 2W plus 80 is equal to 360. Now we have a couple of W terms. Let's combine the 2W and 2W to get 4W. Plus 80 equals 360. So now to get W by itself, we'll subtract 80 on both sides. We get 4W equals 280. You can divide each side by 4, you're going to get 70. All right, so now we know the width is 70, and in this problem we're working with yards. Now to find the length, notice we have an equation for that. Equation solved for L. The length is equal to the width, which is 70 plus 40, and we get 110. Now let's check this. One of the things I would encourage you to do with all the word problems, and really with the systems as well, is you can always check your answers and make sure that they work. So first of all, let's see, you can see that the length 110 is 40 more than the width, so that part's true. But as far as perimeter is concerned, whoops, so I just put the answer up there. So if we add up the 4 sides, do we get 360? And I went ahead and did that, and you do get 360, and so this does check. All right, let's move on to number 2. It says 2 angles are said to be complementary if their sum is 90 degrees. one of the angles measures 5 degrees less than 4 times the other angle. Find the measures of the angles. So first of all, I'm going to draw an angle. I should say a right angle, which is a 90-degree angle. And I'm going to label two angles in there, angle X and angle Y. Excuse me. And you can see that X is my smaller angle and Y is the larger. And we're assuming one of them is going to be smaller. It says, so first of all, if there's complementary, we have an equation we can write for that. X plus Y is equal to 90. But we also have that one of the angles measures 5 degrees less than 4 times the other angle. Now we're assuming that the one that's 5 less than 4 times the other is going to be the bigger angle. And so let's say Y equals, now 4 times the other angle would be 4x, and if you want 5 less than that, you subtract off 5. Sometimes people will write 5 minus 4x here. Think of it this way, if you want 5 less than 100, that would be 95. You would take 100 and subtract off 5. If you want 5 less than 4 times the smaller angle, you would multiply 4 times the smaller angle and subtract off 5. All right, so we're going to solve this one also using substitution since the second equation is solved for y. So let's plug in 4x minus 5 into the first equation for y. We're going to get x plus the quantity 4x minus 5 is equal to 90. Now we don't really need the parentheses here. This is just a 1 out front, and 1 times anything is itself. So we get 5x minus 5 is equal to 90. We'll add 5 to both sides, and then you can divide by 5, and you get 19. And so the smaller angle is 19 degrees. Now to find the bigger angle, which we called y, or the larger angle, we have an equation y equals 4x minus 5. So I'm just going to plug in 19 for x, and when you do that, you should get 71. And so there's my two angles. Now to check this, notice that 19 plus 71 does equal 90. The other question is, does y equal 4 times x minus 5? Or does 71 equal 4 times 19 minus 5? And you can verify that that is true. All right, let's move on to number 3. It says the sum of two numbers is 9. 2 times the larger number plus 3 times the smaller number is 2. Find the numbers. So first of all, I'm going to call x the larger number and y the smaller number. Now notice in the second statement it said 2 times the larger number. So it talked about the larger number first, so that's why I called x the larger number. So first of all, our first equation, it says the sum of the two numbers is 9. So x plus y is equal to 9. Then it says 2 times the larger number, that would be 2x, plus 3 times the smaller number, that would be 3y, is or equals 2. Oops, I got a little bit ahead of myself there. So I'm thinking as I look at this that I want to use the elimination method. And so I would like to have a minus 2x there so that I could add the equations and eliminate x. Now I could have chose to multiply the first equation by negative 3, so I would have negative 3y, and I could eliminate y when I add the equation. So either one of those would be fine. I chose to multiply by negative 2. So you get negative 2x minus 2y is equal to negative 18. And we'll just rewrite the second equation. So when we add them together, we're going to get y equals negative 16. And we know that the two numbers add up to 9. That was our first equation. And y is negative 16. So x minus 16 is 9. And if you add 16 to both sides, you get 25. And so our bigger number is 25. So the two numbers are negative 16 and 25. To check this, notice that the two numbers do add up to 9. You can verify that. And then if I plug in 25 for x and negative 16 for y in the second equation, you can verify that that is also true. You can do it by hand or you can throw it in the calculator. All right, let's look at number 4. Excuse me. It says, Wilt Chamberlain once scored 100 points. That's very true. In fact, you may or may not even know who he is. He's an older guy, or, this happened quite a while ago, kind of even before my time. But anyway, he set a record for points in an NBA game, still hasn't been broken. Chamberlain, and by the way, he was like the center before his time, because he was big and strong and athletic like a Shaq. Although I'd say he was even more skilled than Shaq was. But he was just a man among, or how did they say it? A man among boys. He just was so much bigger and stronger than everyone else. He just dominated the game. But anyway, so he only took 2-point and 1-point foul shots. He took a total of 40 shots, or 64 shots. How many shots of each type did he make? In fact, they didn't even have 3-point shots back then. Anyway, so I'm going to go ahead and let x be the number of 2-point shots. And let's let y equal the number of 1-point shots. And so let's see, if he took 64 shots, we could just say x plus y is 64. So this equation deals with the number of shots. X 2-point shots and y 1-point shots. Now the other equation we're going to write is going to deal with the points. We know that each of these x shots is worth 2 points. And so to write the number of points for x shots, you would write 2x. So in other words, if you had 10 2-point shots, 10 times 2, you would have earned 20 points. That's the idea. Now for y, those are 1-point shots, and so we can just write 1y or just plus y. So if you took 30, or if you had 31-point shots, you got 30 points. And this is needing to add up to 100. So this is very similar to number 3. I think I would use elimination here. You certainly could solve for x, or you could solve for y and use substitution, but this is kind of set up for elimination. I could easily eliminate y if I multiply the first equation by -1. Then I would get opposites for y. So let's go ahead and do that. We're going to get a minus x minus y equals -64. And we'll just rewrite the second equation. When I add the equations together, I get x is equal to 36. And so there are 36 2-point shots. We know that x plus y is 64, so I can throw in 36 for x. And when you solve for y here, you get 28. So there's 28 1-point shots. Now let's go ahead and check our answer to make sure this works. Well, certainly 36 plus 28 is 64. So the number of 2-point shots plus the number of 1-point shots does equal 64, which is the total number of shots. And if you plug in 36 for x and 28 for y in this second equation here, you can verify that that does equal 100. All right, let's move on to the last example. It says a high school math teacher spent $36 for some mechanical pencils and notebooks to use as prizes for a game during the first week of school. She purchased a total of 20 items. If the pencils were $1.50 each and the notebooks were $2 each, how many mechanical pencils and notebooks did she buy? Well, my wife is actually the person that I'm thinking of here. She likes to give prizes at the beginning of the school year, and she does work at a high school. But anyway, excuse me. I'm going to go ahead and let X be the number of pencils. These are mechanical pencils. And I'll let Y equal the number of notebooks. So we're just talking about the quantity of pencils and notebooks, and there were a total of 20 items purchased. So we could say X plus Y is equal to 20. We're dealing with quantity. The number of pencils plus the number of notebooks is 20, since 20 items were purchased. The other equation should deal with value. Now remember, she spent, or cost, she spent $36. And so how do we get that? Well, she purchased X pencils, and each pencil was $1.50. So $1.50 times X would tell you the value or cost of those X pencils. So for example, if X were 4 times $1.50, she would have spent $6 for those 4 pencils. So that's the idea. And so the cost of Y notebooks would be 2Y. Now I could have wrote $2, 2.00, but I'm just going to use 2 here. And so now this is our system to solve. Again, I think I'll use elimination here, and I'm going to go ahead and eliminate Y. I can multiply the first equation by -2, and then I'll have opposites for Y. So let's go ahead and do that. We get -2x minus 2y is equal to -40. Let's rewrite the second equation. So when we add the equations together, we're going to get -0.5x. I mean, you can add -2 and 1.5 and you'll get that. Basically minus 50 cents. And the y's cancel. On the other side, we get -4. We'll divide both sides by -0.5x, and you should get 8. So x is the number of pencils. We have 8 pencils. Well, since there were 20 items, x plus y is 20, and x is 8, that would mean that y must be 12. So that means there are 12 notebooks. Now, just to make sure this is right, we've already said that there's a total of 20 items, and 8 plus 12 is 20. The other equation to check would be the second one, so let's go ahead and plug it, 8 in for x and 12 for y, and you can verify that that equation is true. All right, and that's going to be it for this video.